My name is Eric Siegel, and my book is called Predictive Analytics. Predictive Analytics is, well, the shortest definition is the subtitle of my book, The Power to Predict Who Will Click Buy, Lie, or Die. There's two kinds of people who care about predictive analytics. Number one, all the organizations that win by making per-person predictions. This is companies, governments, hospitals, universities, law enforcement, nonprofit, even presidential campaigns. These organizations win by predicting for each person to drive decisions as far as who to call, who to send mail to, who to lend money to, who to investigate for crime or fraud, who to treat in certain ways for health care. By doing this, the organizations win. They decrease risk, healthcare is made more robust, they toughen crime fighting, sales are boosted, for presidential campaigns, more votes are gained. Number two, the other kind of people who care about predictive analytics is everyone else, because these organizations are making predictions on you and I every day. We're being predicted as far as whether we're likely to buy, whether we're going to heal, get better with healthcare, whether we'll drop out of school, whether we're going to commit theft, we're going to steal something or commit a crime, whether we're going to crash our car. So all these predictions, millions of predictions a day, are being made about us by these organizations, largely to our benefit, definitely to their benefit. You don't need to predict accurately to get great value. Organizations, by predicting better than guessing, get a little bit of view through the fog, that blocks between today and tomorrow. So by making these predictions per person that are a good bit better than guessing, they actually play the numbers game better. All organizations essentially are playing numbers games. And the way to optimize the vast operational scale of organizations today is with prediction. Predictive analytics is a big data thing. Well, big data is basically just a grammatically incorrect way to say a lot of data. But yeah, the more data, the better. The more experience, data essentially is experience of an organization, it's the aggregate or collective experience, and the more you have, the more there is from which to learn to create predictive models that make the per-person individual predictions, which will in turn be more accurate or more precise, having been trained or learned over a greater amount of data. So with today's excitement over big data, it's all big data this, big data that, the question it begs is, well, what's the point? What are you going to do with it? What's the most valuable thing you can do with this greater and greater amount of data? And the answer is the most actionable thing that an organization can get out of data is learning from it how to make predictions per person, because those per person predictions drive all the individual per person actions and decisions that organizations make. No, Nate Silver didn't use predictive analytics to forecast the election. However, Obama did. So Silver made forecasts for overall state, overall how would the prediction go, whereas the Obama campaign actually used predictive analytics to make per-voter decisions. So that's really the difference between forecasting and predictive analytics. Predictive analytics makes it possible not just to predict the future, but to influence it by driving these per-individual person decisions by these individual predictions. In the case of Obama's campaign, the analytics group made these predictions to drive campaign decisions. So while Nate Silver competed to predict the outcome of the election, the Obama campaign competed to win the election itself. And the thing that's interesting is, instead of just predicting, how each individual would vote, are they more likely to vote for Obama or Romney? Are they likely to vote at all? It's something completely different. The Obama campaign predicted how likely is it this voter would be persuaded. Can we change their mind? Can we convince them? Will they be receptive to campaign contact, a phone call, a knock on the door? And so by driving decisions with that way, what they call persuasion modeling, also known as uplift modeling, they were actually able to gain more votes within individual swing states towards winning the election. Predictive analytics is powerful in that it produces these insights, these predictions for each individual. In some cases, yes, the thing that's being ascertained about the individual is very sensitive. In the case of retail, is that consumer pregnant? In the case of large corporations, is this employee likely to quit their job? In the case of law enforcement, is this incarcerated convict likely to commit a crime again if they're released? So I like to quote Spider-Man's wise uncle who said, with great power comes great responsibility. Because, predictive analytics, nobody would care if it weren't potent. These things go together, the fact that it's so powerful, but that it brings up sensitive insights. In some cases privacy, in some cases pertaining to other civil liberties issues. But there are some tricky things. There's a lot that needs to be looked at and considered as a society in terms of what to do with this newfound power and how to harness it in a safe way. Well, as far as the underlying technology, there are a lot of improvements taking place in predictive analytics, and let me go over a couple of them right now. Number one, uplift modeling. That's predicting persuasion. That's driving decisions as far as what's going to make the biggest difference. This is what the Obama campaign uses. I mentioned a moment ago. They make decisions per voter. Which treatment, which campaign contact or lack thereof is the best choice for each voter as far as swaying them in the right direction, and avoiding the adverse effect of swaying them in the wrong direction. Very much the same thing with marketing. I'm trying to sell something. How am I going to persuade that person? In healthcare, which treatment, medical treatment or lack thereof, leaves a better chance of the positive outcome for that individual. Same core technology. Instead of predicting what a person's going to do or the action or the outcome or behavior, you're predicting, will this treatment towards that person make a difference in the right direction that we'd like things to go? That's called uplift modeling. Another hot trend in predictive analytics is what's called ensemble models. So it turns out, just like the collective intelligence over a crowd, called the wisdom of the crowds, where a bunch of people might come together and essentially vote or each put in their opinion, and then the overall average opinion turns out to be better than in most individual people, you get the same effect with predictive models. So the mechanisms that make predictions can in some cases be pretty mundane, they can be pretty primitive, but when you group them together, and there's not a lot of science or math, you basically just pull them all together and make them vote, just like people. The models are voting, and then the overall prediction machine is suddenly much better than most individual models. So it's a great way to sort of tweak the robustness and correctness, the precision, the accuracy of how well these predictive models work, simply by grouping them together and pooling them so that they're basically what's called an ensemble model. Well, there's a lot of exciting, really inspirational things going on in predictive analytics. One of them is the IBM computer Watson that was able to successfully compete against the all-time human champions on the TV quiz show Jeopardy, where there's questions, could be about anything. They're intended for humans to answer. The questions are very complex in their grammar. They're written in English, human language. It turns out that predictive modeling, the core analytical process of predictive analytics, is the way Watson succeeds in choosing the answer. It predicts, is this candidate answer the correct answer to this question? And in fact, the way it does it so precisely is using what I mentioned a moment ago, an ensemble model. So it's using lots of models all together. It learns from historical, previously given questions on, from this TV show's history, and is able to compete, get one answer after another. The questions could be about any topic. The answer could be anything. It picks out the one singular correct answer. It's just incredible. You can see it on YouTube. The actual broadcasted episodes of that TV show Jeopardy! Is just amazing. It just rings off one correct answer after another.